All right, we are back at AP Review. This is 2015 AB Free Response 5. The figure here, which is not as good as the one on the AP, so use the actual paper, shows the graph of f prime, the derivative of a twice differentiable function f on the interval from -3 to 4 inclusive. The graph of f prime has horizontal tangents at x equals -1, at x equals 1, and at x equals 3. The area of the regions bounded by the x-axis and the graph of f prime on the intervals from -2 to -1 and -2 to 1 rather, and 1 to 4 are 9. So this is a 9, but it's below the x-axis, so it's a -9. And this is a 12, right? That's a 12, but again below the axis. Cool. Find all x coordinates for which f has a relative maximum. Give a reason for your answer. So remember that this graph of f prime is actually fundamentally already an f prime sign chart, right? When we want, so in part A, right, we want the relative max of f of x, right? So what that's going to mean is we need to use an f prime sign chart, right? We need to find critical points, right? So when we use an f prime sign chart, what we usually do, we start with where does f prime equal 0? Well, I can see on this graph that happens at -2, 1, and 4, right? So -2, 1, and 4, right? Where does f prime not exist? Well, that's not going to happen anywhere here because on this entire window from -3 to 4, the graph exists, right? It's a graph. It exists. Cool. And I have to worry about endpoints because sometimes endpoints can be extrema. So the endpoints are -3 and 4, but 4 was already covered by being a critical number anyway. So what's funny is if you look at this, I can just make a sign chart directly below this graph very quickly and answer these questions. So -3, -2, 1, and 4 are all on my sign chart, right? And this is my f prime sign chart, right? These are my signs of f prime, so I'm going to put a little circle there. All right, so f prime is this given graph, which means that to know the sign of f prime, I just need to look at the y values on this graph and see if they sit above or below the x-axis. So from -3 to -2, right, not including -2, f prime is above the x-axis, so that means that it has positive values, right? It's 0 at -2, it's 0 at 1, it's 0 at 4. From -2 to 1, not including the endpoints, my graph sits below the x-axis, so f prime must be negative because, again, f prime is this given graph. And then the same thing is true from 1 to 4. So what that means f is doing is f is increasing until it gets to -2, leveling out for a sec, decreasing from -2 to 1, leveling out, decreasing again until I get to 4. So the included endpoints are both mins, which was not the question I was asked. This point at x equals 1 is called a saddle. It's not a max or a min. And the only max I get is at x is -2. So my answer to part A is that the relative max is at x equals -2. And the reason is because f prime of x changes from positive to negative, right? That's my reason for why that's the max. Okay, part B. On what open intervals contained in that window from -3 to 4, again, open, not including the endpoints, is the graph of f both decreasing and concave down? Give a reason for your answer. Okay, so let's think about what these two things mean, right? So this is one of those times that you really need to translate what you're asked into what it means mathematically and then what you can see with your eyeballs, right? So let's talk about B. Right? In B, we were asked two things. We were asked, when is the graph concave? So that we're asked about when is f. These are both about f. When is f concave down, right? And when is f decreasing? So those are the things that were asked, right? So let's now translate that into what the definition means, right? By definition, f is concave down if f double prime of x is less than 0, right? But the trick is that that's not what I can see with my eyes, right? What I can see with my eyes is f prime. So I now need to translate this to what I can see with my eyeballs in this particular problem, right? So what I can see with my eyes is f prime, which means I'm going to need the relationship between f double prime and f prime. Well, f double prime is the derivative of f prime, which is the same thing as saying that it is the slope of f prime, which is the given graph, right? So the slope of f prime is less than 0. Well, that's a thing I can see with my eyeballs. When does the given graph have a negative slope, right? And that's going to lead me to get an answer for this half of the problem, right? And it is half the problem because there are two parts to this problem. So if I'm looking for when there's a negative slope, right, A negative slope on this graph means the graph is physically going downhill. Well, it's going downhill in this window until I hit -1, so from -3 to -1, right? And also from 1 to 3. And that seems to be the only windows where it's going downhill, right? So if the f prime graph has a negative slope, then f is concave down. Okay, so that's the first part, but that's not my answer because I have to combine the two answers together, right? The second part they asked me is when is f decreasing? But again, I want both of these things together, and that's going to matter because I'm going to have to overlap my two answers. F is decreasing, by definition, means f prime is less than 0, right? Well, now I have to translate that to what I can see with my eyeballs. Well, based on what I can see with my eyes, right, f prime is the given graph. So what that's saying is when is the given graph below the x-axis, because that's what it would mean to be below 0 for a y value, right? So I look at this graph, and I'm going to see if I have another color that works. I think I have blue. This graph is below the x-axis here and also here, right? So that seems to be from -2 to 1, and then from 1 to 4, right? It's not actually below at 1. But now we're going to look at these together because I don't want these two separate answers. I want the window where the blue and the red overlap. So after all that work, it seems that they overlap in the window from -2 to -1, and again from 1 to 3. So my answer to B is from -2 to -1, U 1, 3, right? So, or you can write it in a different way. I personally prefer parenthetical. So again, you want when is the window where they are both of these things, and that's the window, right? And I gave plenty of justification because if you use this idea of doing a flowchart that says, here's what you asked, here's what it means, here's what I can see, that's more than enough justification. Oh, my bad. And for the record, if you wanted to write it as a sentence, this is essentially what you need to be able to say. You need to convey the part that you can see with your eyes. So the slope of f prime is less than 0, right? And f prime is below the x-axis, right? That's what you'd need to relate if you were trying to convey it just in words. Part C. Find the x-coordinates of all points of inflection of the graph. Give the reason for your answer. Okay, so that's going to tie back in, and I apologize that my graph is a hot mess already. That's going to tie back into using one of those flowcharts again, right? So for part C, we want the x-coordinate of an f point of inflection, right? That's the thing they ask me for, right? So I switched to what the definition of a point of inflection is, right? A point of inflection is where f double prime is 0 or does not exist, and this is the important big piece, changes sign, right? So we already saw the connection that we need to make here in the last part. The connection we need to make is that f double prime is the slope of the given graph. So the thing that I can see with my eyeballs is the slope of the given graph, right? The slope of f prime, which is the given graph, has to be equal to 0 or not exist. Well, we know that this thing doesn't ever have any non-existent slopes because there's no points or cusps or anything. So the possible candidates, right, the possible candidates where I could have a point of inflection are where this thing has a horizontal tangent slope. Well, that's at -1, 1, and 3. Again, I apologize that I've kind of butchered my my graph a little bit. I drew a lot on it. So these are the possible candidates, but then I have to consider, so I should always consider those candidates even if I know they're not all right, because sometimes the AP gives you a point for just considering the possibilities. The second thing I have to worry about, though, is this. The slope has to change sign, right? What you'll see at -1 is there's a slope that's going down, and then the slope switches to positive. So this guy has a slope that switches negative to positive. So that's definitely a yes. At 1, the slope switches from positive to negative, so that's definitely a yes. This is positive to, that was negative to positive and positive to negative. Right? And at 3, negative slope to positive slope, yep. So it turns out it's all three of them, right? Negative to positive. Turns out that all three of them have slopes that switch signs. So the graph has 3 points of inflection, -1, 1, and 3. The way the AP chose to do it is they chose to group these two together and give the same explanation, saying that for both -1 and 3, the slope switched from negative to positive. So the way they explained it is they said at x equals -1 and 3, the slope of f prime changes from, that's not how you spell from, negative to positive, right? And at x equals 1, the slope of f prime changes the opposite direction, right? Changes positive to negative, right? I think you could get away with explaining each one separately, but that's why they grouped them the way they did, which is why I paused for a sec, because I was surprised to see them grouped that way. All right, part D. There had to be a reason they gave us these two numbers in green that I've mostly covered up now, and it's part D. Given in part D that f of 1 equals 3, write an expression for f of x that involves an integral, and then use that expression to find f of 4 and f of negative 2. All right, cool. So we know, so here's 1, right? That's 1. I did a slightly bad job of butchering the graph, but you'll survive. So that's the x-coordinate of 1. So we know that f of 1 equals 3. Right? So based on the first fundamental theorem of calculus, if we integrate f prime of, and I'm going to say t dt, right, from 1 to x, I would get f of x minus f of 1, which is a quantity I know. So what I'm going to do is the expression I'm going to write to find f of x is I'm going to add that f of 1 over and say 3 plus the integral from 1 to x of f prime of t dt equals f of x. So a couple little things just to avoid simple mistakes here. If they want you to write a formula for f of x, then x has to be the thing you're going to end up with when you plug in the bound, okay? But you also can't pick x as the variable of integration, so you have to pick something else. Usually the default is to pick t. You can pretty much pick any letter you want as long as it's not one that's already in the problem. So you couldn't have picked f, you couldn't have picked x. But if you wanted to pick some other weird letter, you could. You could have made this f prime of p dp or f prime of q dq. It'd be weird, but you can do it. So that's the first thing. They asked for that expression, right? Then they ask you to use that to find the other values, right? So I'm going to go ahead and find f of 4. Right, f of 4 is going to be 3 plus the integral from 1 to 4 of this f prime of t dt, right, or f prime of x dx, doesn't matter now because that's not an x anymore. So this is an area that I can find because they gave it to me. The area from 1 to 4 is a 12, right? But it's a negative 12 because it's below the axis. So I'm going to get that this is 3 minus a 12. I'm going to get that a negative 9 is my f of 4. Cool. And then the last one is f of negative 2, right, which I'm going to give myself a little bit of space. We'll do it up top, okay? So f of negative 2 is going to be a 3 plus the integral from 1 to negative 2 of f prime of t dt. Now this is interesting because notice how these bounds are reversed. So that means you can either flip them to normal bounds and then change the sign. So I could make it a minus and integrate from negative 2 to 1. Or I could recognize that since I'm integrating backwards, anything below the axis will come out positive. It doesn't matter to me which way you do that, right? I think conventional wisdom is probably that you flip them and make this negative 2 to 1 f prime of t dt, right? So what's going to happen is I'm going to get a 3 minus, but if I integrated from negative 2 to 1, it would be a negative 9. So I get 3 minus a negative 9, and that means my f of negative 2 is a positive 12.